Solving one-step equations. Why would you use inverse operations to solve an equation? Well, we'll take a look at that and see if we can answer this. First of all, we have to remember that equations are basically like a big balance. And since we want to keep things balanced, we need to think about how we're going to do that. And what we're going to do is use something called the golden rule, which is basically what we do to one side of the equation, you must do to the other side to keep it balanced. In other words, this is the property of equality. And when using the property of equality, we can keep things balanced and even and that maintain this equal sign, which is what we're really trying to do. Now, our goal when we solve equations is to get the variable alone to find out what the variable equals. In other words, our goal is to solve the equation to find out what number makes it true. Now, this is where we get to our question that we were starting at the beginning, which was how? How are we going to accomplish this? Well, we're going to accomplish it by using inverse operations. And by inverse, we mean opposite, and operations will have four choices, right? Adding, subtracting, multiplying, and dividing. Some of them are opposite of each other. Sorry about that. Some of them are opposite each other. Adding is opposite of subtracting, and multiplying is opposite of dividing. So as long as we remember what the opposite one is, we're just basically undoing the equation to get down to the bottom of what's going on. So let's take a look at this question first. X plus 8 equals 15, and let's keep our sides up like a balance, like this will be the middle center of our balance at the equal sign. Because this is adding 8, it's the side where the variable's on, and that's where we concentrate on. Since we're adding 8, what's opposite of that, or the inverse operation, is negative 8, or subtracting 8. Then when we go to simplify, you always want to look and see that these two are exactly the same, because the negative 8 does equal negative 8. We're going to maintain this equal sign all the way through. Well, positive 8 and negative 8 is 0. So since it's 0, it just really goes away. X plus 0 is just x. 15 minus 8 is 7. And we should always check our solutions. What we do is take our answer that we came up with 7 and plug it into the original equation, but replacing the variable with what answer we came up with. And all we do is follow order of operations and see if both sides are exactly the same. Right now, they looks like they're the same, but we need to finish this to make sure. 7 plus 8 is 15, and since both sides now look exactly the same, we can say that x equals 7. Here we have 8 plus 8 equals negative 12. Again, having that 8 in front, sometimes people get confused, but all it is that it's a positive 8. And so because it's a positive 8, we're going to put a negative 8 underneath it. Again, these are exactly the same number. What we put to one side, we put to the other. 8 minus 8 goes to 0, leaving us just with a. Negative 12 minus 8 is negative 20. Again, we're going to check our solution. 8 plus a negative 20, does that equal negative 12? We have two signs. We always want to simplify it. A positive times a negative is a negative. And 8 minus 20 is indeed negative 12. So that works out as well. Here we go again. B minus 4 equals negative 7. Again, opposite, inverse of subtracting 4 is adding 4. That will make the 4's go away, leaving us with D equals negative 7 plus 4 is negative 3. You have to always check your solution. Always, always. Negative 3 minus 4 is negative 7. Since both sides are exactly the same, this is now our solution. Let's try one more, but let's put the variable on the other side. Does it really matter what side the variable's on? No, it doesn't. That just means we're going to concentrate on this side here, because that's the right side, which is where the variable is. So the opposite of subtracting 10 would be adding 10. So add 10 to both sides. Here we know negative 10 and positive 10 are 0, so it goes away, leaving us with Q. And negative 25 plus 10 is negative 15. Again, we're going to check our solution. Negative 25 equals negative 15 minus 10. Negative 25 equals, and negative 15 minus 10 is also negative 25. Because they're exactly the same, this is our answer. Now let's take a look at some of the other operations a little bit. Let's take a look at some multiplying and dividing. Here we have 5x equals 20, and we know that when the variable is right next to a constant, just like that with nothing in between, that there's multiplying going on. So the opposite or the inverse of multiplying would be dividing. So the inverse operation of multiplying by 5 would be dividing by 5. And we use a fraction bar to show our dividing. We know that 5 divided by 5 is 1. 1 times x is x, and 20 divided by 5 is 4. We're going to check our solution, and again, just rewriting the original equation, but substituting our answer in. 5 times 4 is 20. It checks out, so x equals 4. Here we have negative 6x equals 18. We're going to divide both sides by negative 6 because that's the inverse of that. The inverse of multiplying by negative 6 is dividing by negative 6. That becomes a big giant 1 there. Negative 6 divided by negative 6. 1 times x is x. 18 divided by negative 6 is negative 3. Check our solution. 6 times negative 3 equals 18. Excuse me, that's negative 6 times negative 3. It's our original problem. Two negatives do make a positive when we multiply, and 6 times 3 is 18. So our answer is x equals negative 3. Two more examples. This time we're going to do them with dividing. Here we have x divided by 8 equals 5. So the opposite of dividing by 8 is multiplying by 8. And you notice that I've put the 8 up here in the numerator. There's a reason for this. If we move it down here next to this says 8 times 8, which is 64. Doesn't make it go away, does it? So it's really important when we're multiplying, when we have a fraction, that we put it up in the numerator, because again, we want to get that giant 1. 8 divided by 8. There's that giant 1. 1 times x is x. 5 times 8 is 40. We're going to check our solution. 40 divided by 8 equals 5. 4 divided by 8 is 5. So since both sides are the same, our answer is 40. One last one. We have r divided by negative 5 equals 30. And again, what is the inverse operation? Not the inverse number, but the inverse operation. Well, the inverse operation of dividing is multiplying. If we want to keep the same number, whatever it is, right? When we're multiplying and dividing. So, let's move this a little bit out of the way there. Here we go. What that will do for us is give us a big giant 1 right here. 1 times r is r. 30 times negative 5 is negative 150. We're going to check our solution. Negative 150 divided by negative 5 equals 30. We know a negative divided by negative is a positive. And if you have to work this out, if you can't do it in your head and you have to do some work on the side, put it on the side and away from the problem so that it's not considered part of your work. Okay, and we can see that it's 30, so it checks, and so we know r equals negative 150. That's the end of this.